Hello, everyone. We are thrilled to welcome you at the Vettabase webinar. My name is Stacy. I represent Vettabase Marketing. So, till people are coming, let's start with some quick housekeeping notes. Please ask questions in the corresponding tab of the interface. Our speakers will answer them after the presentation is over. Today, we will also have several polls. They will appear in the polls tab of the webinar interface. And of course, the recording will be sent your way after the webinar, and you will be able to revisit what's important to you. Our today's topic is the high-level architecture of a complete MariaDB setup. And our today's speakers are Federico Razzoli, Vettabase founder, and Richard Bensley, a database consultant at Vettabase. So today, Federico will start with discussing MariaDB storage engine, proxy level solutions, backup strategies, and more. And Richard will talk about clustering with MariaDB Columnstore schema replication and adding query rules and some other topics. So let's start the webinar. Federico will be our first presenter. Please take the stage. It's now yours.
Hi, everyone, and thank you, Stacy, for the kind presentation. As Stacy said, we are going to talk about the high-level architecture of a complete MariaDB deployment. I will talk about the general part, and then Richard will tell you something a bit more in-depth about using Columnstore in particular. Anyway, so let's start by seeing what a complete deployment is. And, well, a complete deployment should include, obviously, MariaDB itself, but also a solution for high availability and failover, probably a delayed replica, a solution for, or multiple solution actually, for automated backups and backup testing, monitoring tools and alerting as well. And finally, automation GitOps. But I will actually not talk about this final point, automation, simply because it's a separate topic. It's more generic. It's not only related to MariaDB or databases in particular. And it's a vast topic. So I will just say that you should manage everything I will describe in my talk with some proper tools like Ansible or OpenTofu, or anyway, something that supports the infrastructure as code paradigm. Obviously, it's a big list. There's a lot to say about these things, and I will just briefly mention every point, and I will just briefly give you an idea of what is needed and what you should do. There is no time for a lot of details. So, first of all, obvious question is, where should MariaDB run? Well, the system should be Linux or BSD. I guess that Linux is the primary choice, but BSD systems are also very good, and they're not much different from Linux, so you can use them as well. It runs well on Windows, but, well, for example, you won't have the ability to run Galera on Windows. And also, in general, the majority of users use Linux. So it's better to stick to what other users use, because otherwise you will use something that other people don't know very well. You might find strange problems. Better to avoid that. Anyway, you should have, well, enough memory, of course, which is very vague, but I can't give you a number because it depends on your database. Some databases are small, some databases are big. Make sure that the so-called working set fits into your memory. The working set is the part of the database that is often read or written into. And also the number of CPUs or CPU cores depends on your needs. Should be at least 2, simply because in this way you will have more ability to run things concurrently, but I mean, in production, it should be at least 2. And well, of course, it could be more, could be 4, could be 8, I don't know. Anyway, having a high number of CPUs is usually useless with MariaDB, especially because you can scale out by using replication, and we will talk about it later. You should obviously prefer SSD storage, and well, okay, this might be obvious, but I think it's particularly important with databases, so it's worth mentioning. And as a file system, well, you can use XFS or ext4 with LVM as a volume manager, which allows you, for example, to take snapshots to resize a volume. Or you could use ZFS, which also works very well. And basically, ZFS doesn't need LVM simply because it's not just a file system, it's also a volume manager. So it goes well beyond the scope of a file system. I don't recommend running MariaDB on containers. I think that containers are mainly designed for stateless technologies, which is not exactly the case of databases. And they are meant for technologies that need to scale very fast, in or out. But again, it's not really the case of databases, because a database typically doesn't scale that fast. Okay, you might need to add replicas, and you can remove them later, but it's not something you do extremely dynamically. Of course, I'm talking to the majority of users here. There are always exceptions. But keep in mind that if you are the average user and you want to run MariaDB on Kubernetes, for example, you will add a lot of complexity, and I don't think you will benefit from it. Anyway, any cloud platform that provides pair systems will be fine. So you can use Amazon EC2, Azure VMs, Google Compute Engines, Vultr servers, or whatever you like. Okay, or obviously you can also use pair systems. Now let's start to look a bit also inside MariaDB, and we can find storage engines and plugins. Just in case you don't know what I'm talking about when I say storage engines, well, MariaDB doesn't know how to read or write data, indexes, caches, or how to run transactions. It's counterintuitive, but it's true. MariaDB doesn't know that because there is a particular type of plugins that do these things, and they are called the storage engines. If you don't know what storage engines are and you use MariaDB, you probably always use InnoDB, which is the default, and it's a very good choice for the vast majority of cases. But there are always some uncommon or special cases. So I want to mention some of the other storage engines that exist in MariaDB, because you might want to know about them and maybe install them, try them, and use them for some particular cases. Connect is a storage engine that allows you to interact with remote data in general. So when I say remote data in general, I mean it could be remote databases. They can be MariaDB or MySQL, and then it will use the native protocol. But it can be also something else. It can connect to other databases using ODBC or JDBC. It can connect even to MongoDB. Well, this might sound strange, right? MongoDB is not relational. It has collections instead of tables. Yes, you will see MongoDB as tables, basically. You will be able to use these tables and query them with normal SQL queries as if they were local tables. And the same happens if you use completely different source of data, like data files, including JSON, XML, CSV, or even some other less common or just older formats. It supports JSON, and it even allows you to use the JSON type to interact with a remote API. So you can use a REST service as if it was a local table, just to read data. You can't write data. There is an S3 storage engine, which basically interacts with Amazon S3 or any other service which uses the same protocol. There is one in Google, but there is even an open source implementation of S3, which is called Mini.io. And basically, yes, you can convert an existing table to S3. It will be copied to the remote storage, and it's a very quick way to archive it, but at the same time, the table is still available. So if one day you need to read information, maybe you just need to run a single query, you can do it. It will be slow, and it's expected to be slow, but it's very good, because the alternative would be to recover an old backup from S3, restore it in some server, and then run the query, and then delete it again. I mean, it's a lot of more work. Spider connects to remote databases. Well, not any database in this case. It must be MariaDB. But it is different from Connect because it supports partitioned tables. So you create a partitioned Spider table, and every partition can point to a remote server. It will point to a table which should have the same structure on every server, and basically it is a way to implement sharding in a transparent way, because you will query a single server containing this Spider table, but the query will behind the scenes, the query will be translated into multiple queries that go to several remote services. We have RocksDB, which well, yes, basically it's based on the RocksDB database, but it's a storage engine for MariaDB. Actually, not only MariaDB, it also runs on MySQL and Percona server. But it's slightly different in every variant. Anyway, it is very good if you want to save resources, and in particular compress data very well and avoid write amplification, which shortens the life of an SSD device. And the last one that I want to mention is Columnstore, but I will just tell you that it's a columnar distributed storage engine that is very good for data warehousing. And then I will skip to the next topic because later Richard will talk to you much better about Columnstore. Couple of notable plugins that I think it's worth installing in many cases. User Statistics will provide you with some statistics about how the tables are used, how many read rows or written row for each table, and how much CPU time every user is using, and so on. It's very useful if you want to understand better your workload and maybe debug some strange problem you are having. On staging environment, you can also find the SQL error log useful. It's not the normal MariaDB error log, it's just the log where SQL errors are logged. Of course, if you enable it, you should make it visible for the developers somehow, because it's mainly useful for them. They will find out if they are running some queries that generate errors. But in production, I don't recommend to use that. I recommend to instead log SQL errors on application side and send them to some specialized technology that will help you to filter and find these kind of errors. So let's talk a bit about high availability, not just a single server, but the complete cluster where the server runs. Sorry. So high availability and also redundancies are achieved by replication. And replication in general can be of these types. It can be synchronous or asynchronous, single master or multi-master. And this is true for databases in general, not only for MariaDB. And let's see how this translates for MariaDB in particular. MariaDB has these three types of replication. Asynchronous replication, which was the first type of replication which was implemented, which is still incredibly useful nowadays. Semi-synchronous replication, it's much less asynchronous, as I will explain in a moment, but it can bring some problems in terms of speed. Galera cluster is a proper synchronous or virtually synchronous, I will tell you why, replication, and it's theoretically master-master, but I don't really recommend to use it in that way. Anyway, I'll tell you why in a moment. So let's start from asynchronous. So when you make a write on the data on the master, basically an event is logged into the binary log of the master. The binary log is read constantly and sent to the replicas. The replicas receive it and write it locally into something that is called the relay log. But it's in practice, it's the binary log they received from the master. The relay log events are read and applied to the local data. This happens in parallel, well, if you configure it to happen in parallel. Historically, MariaDB replication was mono-thread, but fortunately, years ago, MariaDB implemented parallel replication. Replicas can be used to scale the rates, of course, because you can always add more replicas, okay? You don't add a lot of work to the master if you do so. And anyway, if you reach the point where you are causing a remarkable workload for the master, you can also attach a replica to another replica, okay? There is no limit to that. So yes, you can use it to scale reads. You should keep in mind that data might lag, replication might lag, okay? In theory, in a sane environment, normally the lag is less than 1 second. But in reality, when something bad is happening for performance, for example, maybe you are applying some big transaction, or maybe the replicas are struggling to catch up with the master for some reason, then in that case, you will see a lag. And in theory, you can have a lag of minutes or hours or even days. So there is no technological guarantee that this will not happen. But of course, you can monitor the lag of a replica. We will talk about proxies a bit later, and basically good proxies have a way to monitor how much a replica is lagging, and if it lags too much, it will not be used. Anyway, MariaDB has GTID, so a global transaction ID. So basically every transaction has this ID, which is unique across every replica. And basically this makes it possible to use master failover. So a certain replica is replicating from master A. Sorry, we have a master A and we have 2 replicas. Master A dies for some reason, and then one of the replicas can be promoted to the new master, and the other replica will connect to it, and basically it will use the same GTID as a coordination, as a coordinate to find the new events to be replicated. So yeah. It's worth mentioning delayed replication, because asynchronous replication can be configured explicitly to be delayed. Okay, so I can say, okay, Mr. Replica, you should not replicate the data immediately. You have to wait 1 hour, 1 day, or whatever interval of time I prefer. If an SQL statement destroys some data on the master, maybe I drop a database, I drop a table, or I just run a delete and I forget to write the where close, okay, something like that, I will destroy some data that I need. But the data are still in the replicas, except replicas will replicate the drop table, drop database, delete. Fortunately, if I have a delayed replica, it will not replicate immediately this statement. So I have the time to recover the data from there and copy it to the master. So semi-synchronous replication is very similar to asynchronous, but the difference is when a transaction is committed, even an implicit transaction. For example, I run an insert without writing start transaction, but it's still an implicit transaction. Okay, so when a transaction commits, basically the master waits until at least one of the replicas has received this data, not necessarily replicated it, but at least received it and logged it locally in the relay log. In this way, if the master dies, I won't lose any data. But of course, there are drawbacks, right? Because, for example, this can cause a delay. So maybe the time to write data can be higher than necessary, or maybe if all the replicas die, the writes will not be accepted. So we can say that, sorry, we'll switch into another topic, which is Galera. Okay, so we can say that Galera is virtually synchronous replication. Okay, what does virtually synchronous mean? Well, from the database standpoint, it is a synchronous replication, because when you commit a transaction, basically the data changes will be sent to all the nodes, and the node that received the SQL statement will wait until the majority of nodes certify this transaction. So certify means they say, okay, this transaction succeeded. But I said that it's virtually synchronous. So why is that? Because a certain client can make a write. The data is sent to all the nodes. The first node returns success to the client. The client immediately tries to select the data it brought from another node, but the other node maybe certified this transaction but didn't apply it yet. Okay, this can happen. It's I mean, it's not very frequent, but it's not even extremely rare. It can happen. So yes, that's why we say it is asynchronous. The obvious solution is that if you read a row you just created, you do it in the same transaction. So if you use a proxy, the proxy will direct all the queries to the same node, and this will not be a problem for you. Anyway, that said, the number of nodes should be odd, okay? Because as I said, Galera is based on the vote of the majority of nodes. It's actually called a quorum, just like in a referendum, right? A referendum needs to reach a quorum. Data conflicts can lead to transactions failures, and they can even lead to nodes to be ejected from the cluster, evicted from the cluster. It can even lead to a complete cluster outage. I mean, it doesn't happen often, but in certain cases, yes, it can happen. That's why I say don't use multiple masters, because if you do, you will have more conflicts, which means more failed transactions. And of course, a higher probability that a node is evicted from the cluster. Large transactions should also be avoided because they need to be sent to all the nodes and certified. So it works better with short transactions, and of course it will also work better if you have a primary key, because the primary key is the way a row is identified. So when you change or delete a row, the primary key will be sent to all the nodes. Auto-increment IDs are not necessarily in chronological order, especially if you use multiple masters. But actually, even if you don't, you probably have some failover, right? So if the node you use as a logical master could crash, and if it does, you will write to another node, and then the other node could write smaller auto-increment IDs than the ones created recently from the other node. It's how auto-increment is designed to work in Galera. And, well, obviously, one of the consequences of what I described before is that a node slowdown can slow down the whole cluster, because every node needs to certify the transactions. So, yes, I described how it works and the pros and cons of Galera. Galera nodes can have replicas, asynchronous replicas. And in this way, you can basically scale the reads better. Of course, it will work even better if you can distinguish between the reads that need to get the most recent data and the reads that can get some slightly old data, for example, up to 1 hour ago, okay? Because in this way, you can tolerate some replication lag for the asynchronous replicas. Is it unrealistic? I don't think so. There are a lot of cases when reading stale data is totally fine. For example, to show some statistics, I don't know how many users are registered in a website, how many products are present, and blah, blah, blah. There's a lot of cases where you don't need the latest exact value. A Galera node can also be the master of a replica, which is actually a node of another cluster. In this way, in practice, you are replicating data from one cluster to another. And in this case, you can use a cluster as the primary cluster and the other cluster as a secondary cluster or standby cluster, which is doing nothing. It is just replicating data. But if the primary cluster will crash, you can use the secondary cluster for both reads and writes. Well, actually, I made a couple of diagrams of how it works. This is what I described. We can have a primary cluster, which is the left one, and the secondary cluster, which is the right one. The data is replicated from one node of the cluster 1 to one node of cluster 2. If the master node crashes, again, you can use replication failover and promote another node of cluster 1 to the master of cluster 2. Okay? So Let's talk a bit about proxies, because, of course, I described what MariaDB can do in terms of high availability and failover, but applications need to send queries to running servers and also distinguish masters from replicas, because they must be able to send the writes to the masters. And the reads can be sent to the masters too, but mainly they should be sent to the replicas. So how do you do this? Well, you can do it with proxies. Okay, that is the purpose of a proxy. Only send queries to working servers, only send writes to the master, and send reads mainly to the replicas. And of course, also distribute the reads more or less equally amongst the replicas. You shouldn't be too paranoid about the last point, because anyway, the proxy doesn't have a way to know if a query will take 1 second or 1 hour. I mean, a small fraction of a second or 1 hour. So, but if it can more or less equally distribute the queries, that is fine for most cases. Why not to do this in the application? Sometimes I'm asked this question. Well, first of all, DBAs would need to update the application configuration to add new replicas, remove replicas, change IPs, and so on. It's not practical. But apart from that, proxies are quite complex, actually. They know how to do it, how to do things properly. Trying to do the same in your application will open cans of worms that you can't even imagine, or will lead to oversimplifications, which will create problems to your workload and your availability. And also, proxy have advanced features that applications can't implement, like multiplexing of connections from the proxy to the database server. So the main proxies are ProxySQL, MaxScale, well, HAProxy, but it's not really a proxy for databases. So ProxySQL is the open source proxy. Okay, it works with both MariaDB and MySQL. Actually, it also works with ClickHouse, I think. It is a good product. It is what I recommend basically always. MaxScale is MariaDB specific proxy, but it is not open source currently. So basically, it is covered by the BSL license. So every version, every new version is not open source and becomes open source with GPL after a certain number of years, which I don't remember, sorry, but you can check the license. I mean, it makes sense to use it if you have a MariaDB enterprise license, because it's actually an excellent proxy, but there is no need for normal users to buy enterprise license just to use MaxScale. They can use ProxySQL and it will work very well for them. HAProxy is also still very much used in general, but not so much for databases, simply because it is not built for databases. It does not understand SQL, for example, okay, because it is a TCP proxy. It can receive connections and send them to other technologies, but it will not be able to analyze your query, find out if it is a read or a write, and send the reads to the replicas and the writes to the masters. It doesn't make a lot of sense to use it, to be honest. I mean, use it for MariaDB. Doesn't make a lot of sense. Proxies can be deployed as an independent layer, or each application server can run a different proxy. Okay. Usually, in this case, you run it in the same server or sometimes in the same container, but this is a bit incompatible with the containers philosophy. So more likely you will use the sidecar pattern. Anyway, basically the idea is in the second case, you will associate one proxy to one application server. If the application server crashes, I mean, if you are using containers, you will destroy it and you will also destroy the proxy. If the proxy fails, you can get rid of both the proxy and the application server and start a new one. So yes, I don't recommend Kubernetes for MariaDB, but I never said that I don't recommend it for proxies. It can make sense. So I still think that the first option is generally the best, having a layer of proxies as an independent layer, because, you can have them fully managed by DBAs, who are free to do anything with them. And there are other arguments too, like you will avoid wasting some resources, but it's less important. The main thing is allowing DBAs to manage the proxies and do it in full. In all cases, proxies can crash, so you should make sure you have multiple proxies. But we will get back to this a bit later. Let's see the diagram of the solutions I described. So this is the case where you have an independent layer for proxies. So every application server can connect to any of the proxies. And the proxy it connects to will redirect the query to the right database server, a replica, or a master. The other case is this. Again, you can think about this as a physical server or a VM or a container or a sidecar or whatever. It doesn't matter. It is a logical grouping. Okay, so when this application runs a query, it will send it to this proxy, and this proxy will send it to the proper database server. So not that I never told you this solution is always definitely better. Okay, I told you my preference, but it really depends from case to case. In every case, there are benefits or disadvantages for every solution. Anyway, let's proceed with service discovery. Basically, as I said, proxies will send the queries to run in MariaDB instances. So if a MariaDB instance fails, it's not a problem for us. But proxies also can fail, like any other technology, right? So the application should only connect to running proxies, but how can we do it? Well, there are solutions. I will talk about HAProxy console, and we'll use it as an example. Well, you might not like it because HashiCorp changed the licenses of its products, including console. So it's not open source anymore, but it's still source available. And I don't think there is any open source alternative. So yeah, source available is better than cloud specific, I think. Please don't insult me if you think otherwise. It's just a matter of opinions. Anyway, but if you use Kubernetes, for example, the mechanism that I'm going to describe is kind of embedded in Kubernetes, because you don't connect to a specific instance of MariaDB. You connect to a service, okay? And the service can be any instance. Of course, any cloud vendor has specific solutions, but I'm not going to talk about specific cloud vendors. So this is how console works. This application needs to connect to a proxy. So to do so, it will know the host name of the proxy, and it will make a DNS query to a DNS service, except it's not really a DNS server. It's actually console, okay? It will interact with the application just like any DNS server. So the application thinks it's interacting with the DNS, and you don't need to make any change to the code. Console, which is actually a cluster for high availability. Anyway, console, I was saying, monitors the technologies it covers, like the proxy in this case, right? It will know which proxies are up and running. So it will return the IP of a running proxy to the application. The application will use this IP to connect to the right proxy. To do this, the application will need to make a DNS request with no caching, okay? DNS requests have a time to live, and basically it should be set to 0. In this way, if a proxy crashes, the application will never remember its address, okay? Sorry for my cough, guys, but it is what it is. So let's continue, and let's talk a bit about backups. Okay, you need to backup 2 things, configuration and data. The first part is sometimes overlooked. That's why I wanted to mention that you should backup configuration. But if you use the GitOps paradigm, you have your configuration written in multiple places, right? In the laptops of your team, in some, I don't know, probably in GitHub or something like that. So you don't need to make a specific backup of it. But if you do things manually, then yes, you definitely need to make sure that you have a backup of every aspect of your configuration. And that's not trivial. Data, well, obviously you need to backup data. We'll focus on this. And to have full resilience, we need to do these things. Automate our backups. I mean, obviously, they should run, for example, every night, every week, or whatever. We shouldn't run them manually. Then automatically test backups. again, automatically. You don't need to test them manually, okay? Because in that case, it will never happen. There was a funny incident that GitLab had some years ago with their databases. Basically, they had 3 different backup strategies. All of them failed, and they were not tested. They had no idea. So they lost some data during an incident. Fortunately for them, a guy just ran a manual backup because he was going to do something dangerous, and that was a good idea. But basically, they found out in the worst way that if you don't test something, you don't have that thing. Okay. If it happened to GitLab, most probably it can happen very well to your company. I don't want to terrorize you, but be aware of it. You should also have multiple backup strategies, precisely because every backup can fail, and there are tons of reasons for that. Maybe you start to use a database feature that is not compatible with that backup type. Maybe some tool is updated, maybe some library is updated, and for some reason it doesn't work anymore. When you try to restore, it doesn't work. Well, you should of course test your backups, but when you get an alert that says that the backup failed, it's kind of too late, right? Because you don't have your latest backup. It's better to have a secondary backup strategy. And you should also have incremental backups, because if I take backups at midnight and then I have an incident at noon, okay, I can restore the latest backup, but I will lose 12 hours of data. It's not funny. And it's not good for most businesses. So if you have incremental backups, you can recover all the data or most of the data. Just one thing, actually, I should have told you what testing backups means. You probably don't need to set up a server specifically for testing the backups, okay? Anyway, if you do, you should make sure it's the same version and the same configuration of your production MariaDB. It's unpractical. In most cases, you can use staging servers to test your backups. You take the backup nightly, you feed the staging servers nightly. And if they fail, you will surely know, because your developers won't be able to test their code the day after. But of course, in that case, you will take a new backup. Or anyway, if you have multiple backup strategies, at least one of them will work, hopefully, right? So let's look a bit more about what this means in practice. In practice, there are these types of backups: snapshots, Maria backup, MariaDB dump, and binary log. Snapshots can be taken at several levels: LVM, at file system level, so if you use ZFS, or at VM level. But if you do it at VM level, you will back up the whole system. I think it's much better you make sure you only include the data directory in your snapshots. And you can do it with LVM or ZFS if you have a volume or a pool just for the data. Snapshots are not copies. Okay, so they are taken instantaneously. And they can be incremental. You can take incremental snapshots. there are downsides. If you take incremental snapshots, deleting the old one can be a slow operation, but that's another topic. Let's not dig into it now. MariaBackup takes a copy of the files while MariaDB is running, and it doesn't take any logs, more or less. I think it takes a short log in the last part, but anyway, it's mostly logless. It uses InnoDB transaction logs to bring the data back to a consistent state. What does it mean? You start to make a copy file by file. In the meanwhile, the server is working, the new data is written, so the data you get are not consistent. But MariaBackup will read the transaction logs, and it will undo the transactions that were committed after the copy has started. Okay. MariaDB dump writes all the SQL statements that are needed to recreate the database structure and also data. It's the slowest backup method. It's also the slowest way to recover the data. Historically, it was single-threaded. Fortunately, this is not true anymore since the next MariaDB major version. Okay, it will have a multi-threaded MariaDB dump. It uses a long transaction to back up all the data. At least historically it did that. Starting from the next major version, it will use multiple transactions, but still, when you back up many data, this can be a performance problem for the other clients that are working with the database. But the very good thing is backups taken in this way can be restored on any MariaDB version with any MariaDB configuration. Okay, so it's very portable, and that's why it still exists and it still makes a lot of sense. The binary log, well, I already mentioned it talking about replication. So basically, it contains the changes made to the rows or the SQL statements made to, issued to make those changes. A human being can analyze it using the MariaDB binlog utility because it's written in a binary format. It should be periodically copied to elsewhere. So if you lose the container or VM or physical server or disk that contains the database, well, you will still have the binary log and you will be able to use it as a incremental backup. Couple of words about monitoring. So a good and well-configured monitoring system shows detailed metrics about MariaDB performance, of course, and allows easy customizations because every case is different. Maybe for you, it's very important to monitor something. And for me, for my specific case, it's more important to monitor something else. And it also sends meaningful, non-redundant warnings. So you shouldn't get 55 different warnings caused by the same problem, okay? Because the same problem is visible from several metrics, okay? Okay, it's good that it is, but you shouldn't receive a flood of warnings. And it should send of course, critical alerts at every time, but they should be actionable alerts, okay? They should tell you what is happening and you should know what you should do. The best ready-made solution for monitoring MariaDB itself is PMM. It includes query analysis, which is also very good. PMM is made by Percona, and if you don't know it, you can find a demo online. Some monitoring systems have, or actually probably most monitoring systems, like Zabbix, have templates for monitoring MariaDB or MySQL. So if there is a template for MariaDB, it's better. If you only can find a template for MySQL, maybe some MariaDB specific metrics will be missing, but still it should be usable, right? Or you can also build your own solution. You can use, for example, Prometheus and Grafana, use an exporter to send the variables and the status variables and other information to Prometheus itself, and you can use Grafana to visualize what you have in Prometheus. And for query analysis, you could use the ELK stock. ELK is Elasticsearch Logstash Kibana. Kibana is for visualizing, and it has a very good query language which resembles basically regular expressions, and it allows you to query any information related to a log entry. If you don't like Elasticsearch because it changed its license, there are open source alternatives like OpenSearch. You can also use a solution for monitoring an application and the database response times. So basically, monitoring the database is good, but in the end, what your company provides is an application, right? So monitoring an application allows to see the response times of each call, and basically with a good monitoring solution you will also be able to break it down and see what actually took time in a response. So for example, this is I don't remember what it is. Sorry about that. It's not New Relic, it's one of the alternatives, but anyway, whatever it is doesn't matter, because I don't want to talk about a specific software. I want to talk about a concept. You can see that basically these are the response times, and you can see that each call can be broken down because there are colors. Each color represents something that took time, okay, during the response. And the violet part is Postgres. Other parts include GraphQL, Node.js, external requests, Redis, WebSocket. Okay, so you will know how much of that time was caused by the database. If it's not much, you will avoid wasting time looking into a problem in the database. If it is actually a lot of time, you will know that you need to look into query optimization or maybe some other problem in your database. So sorry, I went very long, but this was my last slide, fortunately. So I believe I can finally leave the word to my colleague Richard.
Hello. Okay.
Hello, Richard, and sorry for taking a lot of your time. Unfortunately, it took long.
No, it's fine. I think we're going to have I'll make it brief for the rest of the attendees. If you're ready, I'll swap screens.
Oh, yes, sure. Sorry, I should actually start stop sharing my screen. Yes.
Okay, let's see how this goes. Okay, how's that? Nods of approval.
We can see your screen. It's all right.
Fantastic. Okay. Federico has already covered a lot of ground, but I'd like to spend the last 5-10 minutes just covering some things which we feel is also important to your overall managed estate. It's not just what you've got and where you've got it, but what is coming in and out. I'd like to just discuss a little bit of the data lifecycle within your MariaDB environment, particularly using Columnstore. And I think what's important, what we'll be touching on today, is all of this is readily available. It's there now. It's probably just an extra package or a plugin away for you from existing package manager, whether you're using Community or Enterprise, MariaDB. I'm not going to be touching on anything that's completely foreign to the ecosystem. Everything is ready to go. Last month, we'll talk about two things really here, like how to kind of scale your workloads and keep your workloads scalable. I'm not going to talk about scalable analytics. I actually did in the webinar last month. So you should go ahead and watch that. Because if you're already using time series metrics, you've got this kind of like large batch scale data. Just throw it at Columnstore. Terabytes have it. Just go. Don't listen to me. Leave now. Go do it. You don't need any of this. I'm talking about how to use Columnstore and Data Warehouse to complement your OLTP workload, your online transaction processing workload, what you're doing in replication, synchronous, semi-synchronous, Galera, anything like that. Transactions come in and out. And what does this environment look like to you? So it's probably InnoDB behind the scene, and you've already tuned your individual servers or your small cluster estate to kind of handle this on like a per node basis. This is just an example. Perhaps you've got about 2,000 connections. That's what you're trying to get aim at with this kind of hardware. And your application backend developers are expecting milli-microsecond return and latency on queries. Nice and fast. Data comes in and out, and you want to maintain that kind of performance on this kind of hardware, be it a virtual machine, hardware, anything, for about 3 to 5 years, perhaps to maximize returns. And perhaps this is what your estate kind of looks like, what your kind of workload looks like. Clients into a proxy, some kind of scaling solution for perhaps reads, writes, and maybe an offsite backup as well. As time goes on, you've got more data and you need to access it. Someone has the genius idea of creating a data warehouse. Okay, pretty good. That's a good first step. You're using the tools, load data, selecting to out file, CP import, or something like this. You're loading into a data warehouse. You're separating the workload, and you're starting to separate concerns, which is pretty good. This data warehouse can now start getting larger, whilst your lean, mean OLTP machine can keep doing the main churn. And those kind of extra reporting workloads, analytical workloads can be handled elsewhere, perhaps by the back end or a client. They know that the data is elsewhere. The only problem with data warehouse and this kind of hardware is it's a bit big and it's a bit expensive. And as time goes on, you often find that other people and other systems also want to use that data warehouse. And that's when things start getting a little trickier. So maybe if you haven't already done so, you should have made your data warehouse MariaDB Columnstore. Plenty of people pushed OLAP and queuing dimension techniques onto relational databases like InnoDB. If you perhaps already done this in Columnstore, or you're about to do this in Columnstore, your world is about to get a lot more simple. Unlike the rest of the ecosystem, Columnstore has its own method for scaling, and it's not replication or two-phase commits over a protocol like Galera. It has its own method of storing extent maps. In this kind of 2-diagram example, 3 nodes in each, 3 servers in each, and on the left-hand side, we're just sharing storage, perhaps that's NetApp, NFS, iSCSI, something or other, a DAS or NAS, and on the other instance, on the right-hand side, that storage is actually then backed by S3 or an S3 compatible storage layer. So you kind of push that concern off to the cloud, or at least an S3 compatible storage solution. So again, this will make your life so much easier, and your data estate can just grow and grow and grow, and you don't really have to worry about it as long as you've got the storage. And it's a wonderful solution, but it is separate to scaling MariaDB in the more traditional senses. So it does require a little bit of extra reading, or some expert consultants come and set it up for you. I'm going to keep saying things like Columnstore is very fast. It is very fast. And these are some metrics from last month's webinar, where I thought it'd be fun to try the 1 billion row challenge, which kind of became popular around January this year. And there's records and things kind of being set on that. But I kind of started with the baseline generation, and it took about 5 minutes loading that billion, and it generates 1 billion rows of data, a location and a measurement in temperature. And this billion rows took about 1:20 hours just to load into InnoDB. Loading it into Columnstore took 14 minutes. That's a considerable ramp up performance. And if you have a cluster, it will distribute this data among the extent maps, among the storage, so that all the cluster can access the data. Very nice. One more from the same challenge. To actually run the calculation, it offers you a baseline on how to calculate this average. And I got 3 minutes 22 just in the baseline Java, and then 52 seconds in Columnstore once it was loaded. And then nearly a quarter of an hour with just a regular InnoDB table. And I think it's important to note here, this is a different workload that is much more suitable to Columnstore for things like metrics and reporting, large-scale analytics, and in this case, between the Java InnoDB and the Columnstore query, we're running groups and sums, so aggregate queries, which it just rips apart. Off it goes. The workload kind of will start to seem very simple or familiar to. Oh, I've made a mistake there. That's not a select into out file on the last one. That's actually load data in file, that's supposed to be. So you're probably quite familiar with perhaps selecting into an out file, having that file, loading it into Columnstore. So just as I did in that previous slide, the load will be very, very quick depending on your data size. You'll probably be doing upload archive or elsewhere to S3, and that'll probably be your option for reloading data should you need to. An important difference with any data warehouse or business intelligence solution is it shouldn't be your only source of truth for the data. It's just an option to start scaling your data estate. Sorry, that bottom one should be load data into out file. Load data from out file. It's not your only option kind of for spreading the load among your servers and things. If we think back to that original diagram where we had lots of kind of OLTP solutions kind of layered over each other and overlapping, you can start doing what I would call separation of concerns. And if there's one database system and server which has an inventory, for example, of goods in, and the sales team would like to see that inside another database, you can always use the Connect engine to read from that table from another database. This is particularly good in the case of things like access control layers. These two systems maintain their own access control layers. They have their own separate users and groups connecting to them, but a DBA or admin can allow access between these two servers, making the data between them a bit more transparent without actually having to move any data. And that's a big important. What's largely important about this idea is we haven't actually had to move any data. Sales is going to have its backup, inventory is going to have its backups and restore routines, and neither shall the twain meet, other than the occasional select query. The S3 engine has been an absolute savior for a lot of people. Again, this is separate to Columnstore. The Columnstore has an S3 compatibility layer to it for just storing data. The S3 engine is superb for handling things like archiving data. So again, perhaps we need to keep our OLTP servers lean and mean, move that data elsewhere, but we can still query it if we want to. But we do understand that we're adding a lot of network latency, and the whole round trip as the query comes in, it has to read to the start of the table. You'll probably be joining onto an archive table. That query has to finish, come back, return the rows, push it up to the client. So depending on the data size, that could take quite a while. And in this example, I'm kind of creating a goods in archive, which both these servers can see because there's one table in S3. And I just kind of created a table like the goods in archive. The goods in, created an archive, start transaction, select from one to another, perhaps where it was last year's data, deleted from the current one. When I did the alter table to engine equals S3, I was able to choose a custom algorithm, compression algorithm. And it's worth noting, this is a read-only operation. This is a great thing to do when you have to actually just push data away. And, it's elsewhere, perhaps you've done a backup, that's offsite. This archive has now been moved to S3. It's still accessible, but it's not updatable. So you're going to have to prepare to have that kind of process where you read it back, update it, push it back again. So it's good for older data that doesn't need updating anymore. Perhaps depending where you are in the world, you'll understand what your legal concerns are, like SOX compliance or GDPR, what you can have and where it can be. So we've kind of seen like a couple of rushed examples there of how what it looked like before, what it looks like now. So we understand these are MariaDB solutions, and perhaps a lot of them are looking at Columnstore in the background, and we can start scaling these things independently. And they've all got their own kind of options for backup and moving data around, but it doesn't really make anything more transparent or as easy to see for the rest of the estate. As we come back to Federico's example of focus on these kind of components in the stack, which is the proxy. And I've actually added one more example here, which is the back end, because your developers or the product owners will know what is an acceptable query, or perhaps in their ORM, they'll know how to generate a query which can go to different servers. If people are familiar with like the Java drivers, you can have specify your replicas in a connection. So you already know that you can push off different rule sets like read and writes into different directions. Perhaps your writes will always go to the primary, your reads will go to a replica somewhere, but that's not always the kind of flexibility that you need. And that's where things like MaxScale, ProxySQL will allow you to then to write rules to be very specific about this query goes here. And in this case, I've just kind of been a bit aggressive, and I said anything with like an aggregate query in here. So select something sum, or select something average is going to the column store. And like I said, it's a bit aggressive, but you can absolutely make sure they go there. You could be a lot more specific in the rules there to make sure perhaps you're joining on different tables or different date or value ranges to make sure they go there. Or again, kind of put that into your back end, or both. So there's a lot of options there for managing the estate to kind of start keeping this spaghetti mess from becoming too difficult or awkward to start owning. And so people say to you, where is this record, or how can I find a record from a particular year and join it and compare it to like a newer trend that we're getting now? As many of you have probably found out over the years, or your other teams have said over the years, no, we don't have everything in one database, or it won't fit in one database anymore. It's affecting the SLA. It's affecting the time of backups, time of restores. We can't guarantee a fast enough solution without making compromises. Well, we're suggesting don't make compromises, just to expand the estate a little bit, maintain MariaDB compatibility, and just push things off to where you need to, and absolutely stay in control of it. So there's a little bit brief. I didn't want to take up too much of your time there. Should we stop for questions, Stacey?
Yes, I think we have some questions, some new questions on the questions tab. Can MariaDB dump data table by table and keep the data consistent to have multiple SQL files instead of a big file?
Yeah, I could partially answer that one. It's the tab option, and I believe it does support a single transaction.
I think I have an answer for that question. Okay, you mentioned you want to get a file per table, if I understand correctly. So, and you want the data to be consistent. So, I think it will be doable since the next major version of MariaDB. But it is also doable currently with MyDumper. The only problem is MyDumper is mostly for MySQL. So if you use MariaDB specific features, it's possible that MyDumper won't work. But again, it should. Test it, please. Don't take my word on it, but I think it will work.
Anyway, let me read aloud another question by Sebastian. Probably Federico has something to add. Would it be okay to leave user statistics to run all the times? Will it impact resources usage on a big database, for example, 1.5 terabyte database?
It is generally okay to leave it on all the time. There is only one drawback. If you have really many users, it might take too much memory. That's why the same plugin in Percona server has an option to limit the memory it can use in these cases. But for MariaDB, it doesn't have this option. So basically, if you don't have a lot of memory and you have a lot of users, that's the case when it can bring some problems. But it's not common anyway.
So another question. What is the state of Docker image? Okay. I guess the one for Columnstore.
Yeah, I think Richard has the answer.
Yeah, if you're referring to the Docker Columnstore image, there is we did release kind of a version that kind of worked. I was working on migrating some of the bash scripts in the background, which kind of pull it all together to Supervisor D to run the write engine, DDL proc, DML proc, worker node, controller node, and another process to Supervisor D, but that has not gone to plan. I think perhaps a better approach would be trying CMAPI within inside each node instead, and keeping that as a front end for trying to run the processes and keep them running. That's been by far the biggest problem in that, and as Federico mentioned earlier, and I can say with definite experience about running large MariaDB installations in Kubernetes in the cloud, it does not work well. There are so many external processes that run. And they wouldn't be fit for sidecar containers either inside something like Kubernetes. So I think we'll still have another go at it. When we kind of talked about that we were doing this, we also mentioned that we've linked a couple of tickets, one to the MariaDB Enterprise team to get it updated, and one to the community team for the foundation team to perhaps get Columnstore better integrated into the MariaDB server process, so there's fewer external processes. And I think that's been the biggest problem. It just runs so many external processes, and containers are processes. So in progress is my still in progress is my answer for that.